Your arc can have a lot of different looks. You can choose to have your arc with a fill, or with no fill, or with a stroke, or without a stroke. So it can give you a lot of different options. You can, remember, you could put like no fill and then a very thick stroke, something like that. You can also, your arc can have lots of different endings. That is going back to what I'd like you to reference. I'm not going to cover that. I'd like you to reference that on the processing site. If you want it to end, here it is ending with open, and you see how it's not connected. Or if you do want it to be connected, you could end it with chord. So different types of endings here. So please do check out what is here on the processing reference. But I know that it's a little bit strange. We have to deal with radians, which is a new unit of degree, and it's a little bit different. It has this start and stop than our other shapes. So even though it is a 2D primitive, like the ones we've covered. So what goes into an arc? We have, this is how they list it on their site, A, B, C, D, start and stop. Okay, well the A and B, that's just what you would expect. That's the X and the Y position. The C and the D is the width and the height. So far this is like an ellipse. X and Y, that's my middle point, and then my width and my height. Then start and stop. So this is something that's a little bit different. So what is start? It's where does the arc start, and stop is where does it stop. Alright, so I'll go over these all. The first thing is to notice the X and the Y isn't here. You know, it's not like on what we actually see. The X and the Y comes from, we have to imagine this slice as being part of a circle. So over here, you can see it's kind of faint, but do you see like my pink circle here? So the X and the Y is the middle point of this circle. Go back to one of these Kandinskys. So if I want to draw this arc, this is my X and my Y, the middle point of if this would be a circle. Okay? So hopefully that makes sense. Going back over here. The width and the height are also from that imaginary circle. So again, I think the confusion can be that you would think that this is the width might be this and that this is the height, but it is, you have to imagine a full circle. So going back to this one, this is my width and this is my height. So you're just drawing a circle. That's all you're doing. Or an ellipse, because the ellipse takes 4 arguments. So you're putting this X and Y, you're doing the whole width and the whole circle. So the thing that makes it an arc is the start and the stop. And that is the weirder part. Not hard, but the weirder part. So the arc, the start and the stop always goes clockwise. So if, imagine I had an arc that looked like this. This is my start and this is my stop. If I had an arc that looked like this, I wish I had a pen or board in front of me, I could just draw it. So kind of where I'm going like this, you can imagine this is the arc, this is my start, this is my stop. You can never go counterclockwise. The other thing is the units. There are 3 different units that you can declare for your start and stop points for the arc. You can use the units of pi, radians, and this is really the one that I want you to use, or degrees. So I have also on Blackboard a little chart here, and so you should download this. This has all 3 of them. On the outside we see pi, and pi just goes in big chunks. So this is 0. Then as we're going around, right over here, this is quarter pi. Here, down here, what would be 90 degrees is half pi. Over here is pi. Up here, notice how it's written, pi plus half pi. And that's with underscores here. And if I've gone a complete circle, 360, this becomes 2 pi. So if I had an arc that went from here to here, going clockwise, this would start at pi plus half pi, and it would end at 2 pi. The most common mistake I see is that people end it at 0. Well, that would be going backwards. It's at 2 pi. All right, so this is one way, but the problem with this method is you're just stuck at these like big chunks. And it also gets really wordy. I mean, like, if I wanted to be here, I could say pi plus half pi plus quarter pi, but that gets like a little bit on the wordy side. So this is what it would look like, and you can find all of these examples on the processing website. But so, for example, I have an arc. This is my x and my y, my width and my height, and because I want it to be a circle, they're the same. I start at half pi and I end at pi plus half pi. So let's just pull up my little circle here. See if I can get these guys to be side by side. Yeah, kind of on the small side. So that would, no, not what I wanted, sorry. So that starts here and it ends at pi plus half pi, so that would end here. So this would be a half circle over here. My next one, I can scoot this over, is another way you could write it, pi divided by 4, which is the same as writing quarter pi. So this one starts here and it ends at half pi, ends right here. So this would be a small little arc. You could either write quarter pi or pi divided by 4, same thing. My third one here is pi, which is here, 2 pi. So that would be like my half circle up here, what it would look like. And let's just throw one of these into processing. And I want a size. 500 by 500 is the most common size that I use. And here's my arc. So let's just see, what does it look like if I didn't have my width and my height the same? What if I made my width a lot more? So this is a way, it's not the way arcs are intended to be because they're supposed to be a partial circle, but you can get some of the shapes that look a little bit like what you might see in Kandinsky. This is not a true arc, it looks more like a curve, but this is just one way that you could take an arc and kind of tweak it. So it looks more like a curve if you find that you like arcs better. Now if you wanted to use degrees, if you prefer to use degrees on that chart, you can. This is how processing will convert them. First you put radians and then you put the degree number. So this is going from 45 degrees to 90 degrees. 90 degrees to 180 degrees. So if you prefer to use that method, just zoom in here on this chart. So if you prefer to use that method, the inside numbers are degrees. So if you wanted to, if you had something and you felt like it went from about here to here, you would just put radians and then in parentheses 20 and then radians in parentheses 140, and that will convert it to degrees.